Good afternoon, everyone. Today we are going to talk about the Polygon architecture. What is Polygon? Well, essentially it's a blockchain that is developed on top of Ethereum as L2 technology to solve the famous scaling problem of Ethereum. We know Ethereum is pretty good, very popular. However, one of the limitations of Ethereum is it's too slow and the gas fee is too high. For example, only 15 transactions per second. Easily you can pay up to 20 to over $100 for one transaction. So here's the Polygon architecture. Essentially, as we talk about, it's built on top of Ethereum. So this Ethereum usually is called main chain or root chain. And here there are three Polygon related contract called staking contract, checkpoint contract, rewards contract. Of course, staking contracts are used for people. They can stake their Polygon native token Matic over here. And then checkpoints, people can use this contract to save the change of state in the checkpoint over here. And the rewards contract is going to reward people because people stake their contract. So, and then the other two layer is handle, which is for the proof of stake. Basically, it's going to validating the blocks from the sidechain Bo. So Bo is a sidechain which contains the EVM, Ethereum virtual machine, and it supports fast consensus. So let's talk about the stake contracts. Stake contract is of course used to enable proof of stake, and the purpose of a stake contract is used to enable anybody can stake Matic token here, and then join the system as a validator. So if you want to become validator, you have to deposit some Matic, and then you're able to earn rewards because you validate the transactions. But in the meanwhile, you are going to be subject to penalty and slashing of the tokens you stake, because if you do something like a double signing or you have a validated downtime of your machine, then you're going to be penalized, and then some of the Matic is going to take away from your account. And of course, the main purpose of this is also is able to save checkpoints on the Ethereum mainnet. So they are the one who is doing it, right? The validator. And the handle is the proof of stake layer, which is going to periodically publishing snapshot of the both side chain onto the Ethereum. So it consists of three functionality. First, it's going to validate all the blocks since the last checkpoint. So this is more like a database technology. And then creates a Merkle tree of the block hashes. And finally, it's going to publish the Merkle root hash to the Ethereum mainnet. Let's give an overview of the process in the handle. So a subset of active validator from the pool is going to be selected to act as the block producers for a particular span. So each span, which is a period of the time frame, only a subset is going to be responsible. So it's like a committee selection. And these block producers are going to be responsible for creating blocks. So not everybody is eligible for creating block. For a particular span, only a subset. And then they will be broadcasting the created blocks on the network. A checkpoint includes the Merkle root hash of all blocks created during that span. So that's the one checkpoint. So one checkpoint is basically the Merkle root hash. So each checkpoint is going to contain, in particular, the Merkle root hash of all the blocks. And then all nodes validate the Merkle root hash and attach their signature on it. So everybody sign a signature on that particular Merkle root for that span. Then a select proposer from the validated set is responsible for collecting all signatures. So it's like the leader, like the committee chair, for a particular checkpoint and committing the checkpoint on the Ethereum mainnet. And that's the job of the selected proposer. The responsibility of creating blocks and proposing checkpoint is variably dependent on validated stake ratio in the overall pool. So the more you stake, the more opportunity you are going to be assigned as the active validator as well as the proposer. Finally, the bool is a sidechain which corresponding to a sidechain block producer. So this is the entity that is responsible for aggregating transactions into blocks. And bool block producer are a subset of a validator, which are selected based on the amount of stake they put into the contract. And they are going to be shuffled periodically by the Hindor validators via committee selection. So it's not going to be fixed. The set of block producer is not going to be fixed. In duration, 10 is a span. So each span is going to be like a different committee. Blocks are produced at the bool node. The sidechain virtual machine is, of course, Ethereum virtual machine. So this is why a lot of people like Polygon, because whatever development experience you accumulate over Ethereum is not going to be wasted. You can reuse and leverage those experiences you learn on Ethereum and then become productive and successful on the Polygon blockchain. And blocks produced on bool are also validated periodically by the Hindor nodes. Finally, as we mentioned earlier, a checkpoint consisting of the Merkle tree hash of a set of blocks on bool on that particular span is going to be committed to Ethereum periodically. But of course, when you do transaction on Matic, you need to have the native currency of Matic. And I tried to buy some Matic on the Coinbase. Turns out Coinbase doesn't actually support native Matic. Actually, they are Matic representative on the Ethereum chain. So then the question is, where can I trade some Matic? Well, I would prefer to use FTX.us because you can enjoy 85% trading fee, also 5% of discount if you register your account today by this URL. And on the other hand, Coinbase, as I mentioned, if you're trying to sell your native Matic to Coinbase, you're going to lose it. Many people lose it. I lose some. If you search Google, actually millions of dollars already wasted. People saying they have been mistaken and Coinbase doesn't support native Matic. What a shame. Well, hopefully one day they will, so that those $1 million, and including my part, will be recovered. So that concludes about today's discussion of Polygon's architecture. Enjoy.